Dear all, now we are going to see greedy layer-wise pre-training in deep learning network. So what is meant by greedy layer-wise pre-training means it is a technique to build deep neural networks. It is used in deep neural networks. It trains one layer at a time. It uses greedy approach. That means it finds the best setting for a single layer without worrying about the rest. So it stacks training layers together. It helps the network learn better comparative to other training models. So why to use this greedy pre-training model means in the early days of artificial intelligence, deep networks fails. Wait, that means rules for making decisions were random. Our networks got stuck and could not learn. Think of building a tall house of cards. If you build it at all once, it fails down. If you glue the bottom cards together first, the house stays strong. Pre-training works like glue for your model. It sets good starting rules for each layer. So these are all the steps. Train layer 1. Take your raw data, train the first layer using unsupervised learning, freeze and extract. Save the settings for this layer so they do not change. Pass the data through it. The transformed data is the new input. Train layer 2. Train the next layer using this new input. Repeat this for all layers. After that, fine tuning occurs. Put all layers together. Add a final output layer. Now train the whole network using labeled data. So these are all the steps we need to follow. So training deep neural networks for traditionally challenging due to the vanishing gradient problem. In this case, the weights in layers close to the input layer were not updated effectively in response to errors calculated on the training dataset. To overcome this problem, researchers adopted greedy layer-based pre-training. As the number of hidden layer increases, the error information propagated back to early layers is significantly reduced. Consequently, the weight in hidden layers near to output layer are updated normally, while those closer to the input layer receive minimal or no updates. This issue, known as vanishing gradient problem, historically preventing the training of deep neural networks. To address the challenge, researchers introduced greedy layer-based pre-training, also referred as pre-training, which facilitated the development of deep neural network models. So layer-based pre-training means pre-training involves successfully adding a new hidden layer to the model and refitting it. It allows a newly added layer to learn from the outputs of the existing hidden layers. The weight of existing hidden layers remain fixed during training. This technique is called layer-based because the model is trained one layer at a time. It is referred as greedy due to its piecewise approach to training deep networks. By dividing the training process into multiple layer-based steps, the model follows a greedy optimization process. This approach serves as a shortcut that leads to an aggregate of locally optimal solutions instead of a single globally optimal solutions. So there are two main approaches for pre-training. They are supervised greedy layer-based pre-training and unsupervised greedy layer-based pre-training. In supervised pre-training, adds hidden layer to a model trained on a supervised learning task. In unsupervised pre-training, it uses the greedy layer-based process to build an unsupervised autoencoder model. Later to this, a supervised output layer is later added. So this is the pre-training process. In layer 1 training, train the first layer on raw unlabeled data which we are giving as input. The next one in layer 2, freeze and feed. Use L1's output to train the second layer. Repeat, continue this process for all the hidden layers. We need to do for all the hidden layers. After that, combining layers, stack all the layers and add a final output layer. Then fine tune the output, train the whole network with labeled data. And finally, this fine tuned output is received to the users. So greedy layer based infrastructure is explained in this using autoencoders. So many layers of autoencoders are implemented here. So the first layer is trained as an autoencoder to learn from the input data. So the first layer's learned representation is used as input for the second. The figure shows the greedy layer based autoencoders. So the data is passing between the hidden layers layer by layer. First autoencoder passes some input to the second autoencoders. So the pre-training process is continuing layer by layer. So the pre-trained layers are combined and the full network is fine-tuned here. So classifying images is applicable in the output layer. So combining layers after pre-training is represented here with input layer, hidden layer and output layer. So the parameters of each layer have been determined. Is then it possible to perform supervised fine-tuning is also applicable in the layer-based training. So the pre-trained layers are combined and the full network is fine-tuned. And whenever we are giving some images in the input layer, it classifies the input after the pre-training process is obtained. So key variants here are pre-training can be supervised or unsupervised. I already explained. The heavily in stacked autoencoders and deep belief networks comes from unsupervised learning. Adds hidden layers to a model already doing a task is obtained with supervised learning. So pros and cons: helps prevent overfitting, fixes the vanishing gradient problem, great for when you have a lot of unlabeled data. Cons: slow to train, modern tricks like ReLU, activation functions and batch normalization largely replaced it for standard task. Thank you.